Last time we stopped when we determined that this is a two-sample dependent. And the reason is you have one group of 7 students, and the same students took test 1, and we have the score in test 2. So, are they different? So you say, well, to be different, then they must be not equal each other. You bring this over, not equal 0, and since this is a dependent system, instead of mu1 minus mu2, we use mu d, and that's only for a dependent system. This would be the complete opposite. Now, after we do this for mu d equals 0, not equals 0, we say what that is. Explain what this is in English. True mean of scores scores are not different for students between test 1 and test 2. And say here they're different. Step 2 is determining what test to use. And for this chapter, the test we use is d bar mu d sd square root of n. And I said it before, not equal would be an indication of a two-tailed system. For a two-tailed system, decision rule. We know we're using t, so we say if t more than or t less than minus, reject H0. So for a one-tailed upper tail, you only say t more. If it happens to be one-tailed lower tail, you say t less than negative. But this is two-tail, so more or less than negative, reject. Now, to get this number, we need degrees of freedom. And for this sample dependent, it's only n minus 1. So 7 minus 1 degree freedom is 6. And I believe they give you alpha of 5%. Yeah, so alpha equals 5%, but this time we divide it by 2 because it's a two-tailed system. So you go to the table, degree freedom 6 with 5%, with 2.5 alpha, 2447. 2447. So the number you're going to compare to is 2.447. Okay. After this, we do calculations. But to do the calculation, there are a little bit of work involved. You see the formula, it says d bar mu d sd root n. To do d bar and sd, we need to have the sum of d, sum of differences, and the sum of differences squared. So we're going to add two columns to this. One called D for difference, and one called D squared for the difference squared. And we go 1 minus 2. So for the difference, 23 minus 20 is 3. 20 minus 22 is minus 2. 22 minus 19 is 3. 27 minus 28 is minus 1. 30 minus 26 is 4. 35 minus 31 is 4. And 27 minus 25 is 2. This is the column for D, difference. Here, you take each number and square, and any number you square becomes positive. 3 squared is 9, minus 2 squared is 4, 3 squared is 9, minus 1 squared is 1, 4 squared is 16, 4 squared is 16, and 2 squared is 4. So now, the sum of D and the sum of D squared. Sum of D, you add these numbers and make sure that you keep the sign. So you go 3 minus 2 plus 3 minus 1 plus 4 plus 4 plus 2. This gives you 13. Here you add them. 9 plus 4 plus 9 plus 1 plus 16 plus 16 plus 4, 59. She could ask you to actually do the columns and do the sum of D and the sum of D squared like we did, or these two could be provided. If they provide them, then you're good, you don't need to worry about it. But if they're not provided, then you have to do the calculation yourself. So I'm gonna erase this to allow for some space. So this is the formula now. To find D bar, you take the sum of D, you divide by n. So you take the 13 and you divide it by the sample, and the sample in this case 7. 13 over 7, your D bar is 18571. To do SD, you need to do the SSD, which is total variations, but for the difference. Sum of D squared minus the sum squared over n. Sum of D squared is 59. Sum of D is 13, and there are 7 students. Take the calculator, 59, 13 squared over 7, and that gives you 34,8571. From that, we find the variance, which is SSD over n minus 1. So this number over 7 minus 1. So you divide it by 6, basically. And that gives you 5.8095. And finally, your SD is the square root of variance. It's the square root of this number. You square root this number is 2.4103. So now we have D bar 1.8571. We have SD 2.4103. Your n is 7. What is mu D? Top right, mu D. Go to the hypothesis, tells you mu D is 0. Is it usually? Well, yeah, unless they tell you, and I don't think they would. Prove that they're different by 1, or prove they're different by 2. In this case, this number would be 2, but most of the time it will be just 0. So we are ready to put everything in the t-test. D bar is 1.8571. Mu d is 0. SD is 2.4103 over square root of your sample and its sum. So 1.8571 0.24103 square root 7. This gives you 0.385. This is the answer for your t-test, the 2.0385. Now, once we calculated this, we are ready to make a conclusion. Your t-test of 2.0385. Check this. Is this number more than 2? No. Not more than 2.447. Is this number less than minus 2? No, definitely not less than minus 2447. This number is not more than 24. This number is not less than minus 24. A number less than minus 24 would be like a minus 3 or a minus 4. So neither satisfied. Do not reject H0. Anytime you do not reject H0, you have to say type 2 could be committed with risk equals beta, and you don't need to calculate it. Type 1 risk equals alpha, and that's when you reject. Alpha would be given, and when you don't reject, it's always type 2. So, what is this in English? So if you don't reject, if you're not saying no to this, you're actually accepting it, then there is no evidence that they're different. So we say we have no evidence, we have no significant evidence to show that the mean score for students test 1 and test 2 are different or is different. We cannot prove that they're different. Okay, now the last thing in this is, what if they ask you to do p-value? So what if you're asked to do p-value for this t-test? Again, DTT, degrees of freedom, test, and tail. Degree freedom for this chapter, again, n minus 1, 7 minus 1, 6. We found the test to be 2.0385, and we were doing it as not equal, so we were doing it at two-tailed. Good, so we go to the t-table. We go to the degree freedom 6. Now in degree freedom 6, where do you see this 2.3? I see it, 2.03, I see it between 1.9 and 2.4. I go up, then my p-value somewhere between 0.25 and 0.5. So in the degree freedom, and between the two numbers, 1.9 and 2.4, go up, you're between 0.25 and 0.5. But this is two-tailed. This is the first time we do a problem two-tailed. Since it's two-tailed, then you need to double both percentages. Oh, you put the higher number here. So you put the 5% here, and the 2.5 here. You always put the low and the high. So in fact, you double it because it's a two-tailed system, so your p-value is between 10% and 5%. And if you're asked to interpret the meaning of p-value, like I said in the previous one, assuming H0 is true, the probability of having a sample as extreme as the test equals, or is between 5% and 10%. But instead of saying assuming H0, say what H0 is in words. Good. So now we know that they're not different, or we proved they're not different. I want to do the same question, confidence interval, and see if we prove that really, in fact, they're not different, and if the confidence interval and the hypothesis are consistent. So I'm going to do 95% confidence interval for difference between the two tests. We know it's a dependent system. We figured this out. It's one group performing two tests. Then a dependent system confidence interval, or plus minus formula, is d bar plus or minus t star sd square root of n. To get t star, you need degrees of freedom. It's n minus 1, 7 minus 1, 6. You need alpha. 95, alpha is 5. And you divide it by 2, because all confidence intervals are divided by 2. They're all two-tailed system. So we have the degree freedom 6, and we have the 2.5. Your number from the table is 2.447. Now we put everything together. D bar, we found this to be 18571. T star is 2.447. SD is 2.4103, and a square root of 7, because that's your sample size. You bring the first number down, you do the calculation for the margin of error, what comes after the plus minus. Two, 292, then your mu d is somewhere between, you minus them, you add them. So 1.8571 minus 2.2292, that takes you down to 3721, and if you add them, that takes you up to 4.0863. And you say what this, of course, in English. And let's say if that proved the same thing, that they're not different. Remember when I told you, anytime you do confidence interval difference, it could be negative, negative, positive, positive, negative, positive. These two, you say they're different, 0 not within. And this one you say they're not different, since 0 is within confidence interval. So now look at it. Negative, positive. Use this case. They're not different since 0 is within. So same conclusion we got when we did it as hypothesis testing. Now, for the actual midterm, I think the questions are done, except there is a bonus question. She usually throws a bonus question. They're usually quick questions. I'll do 2 of them from 2 different tests. It's not probably gonna take about 10 minutes or so. When estimating the difference between 2 population means, what can be done to reduce the margin of error in the estimate? So, and she doesn't say, this is the first bonus question, she doesn't say whether it's independent or dependent, but you know the formula. If it's independent, it would be average 1 plus or minus T star SP 1N1, 1N2. And if it's dependent, it would be D bar plus or minus T star SD over square root of N. And we did examples for both. And I said before that when we say margin of error, we mean what comes after the plus minus. This is your ME margin of error. Not only for these confidence interval, for any confidence interval, what comes after the plus minus margin of error. To reduce this, you could decrease the T star value. And the way to decrease T star value is to decrease the percentage of confidence interval. So decrease confidence interval percentage. So instead of 90%, go 85% confidence interval, or 80%. So decrease the confidence interval percentage. You can also reduce the value of your standard deviation by increasing the sample size. Involved. So anytime you increase the sample size, here for group 1 or group 2, or here or for the group, that would also reduce your margin of error. And if you decrease the percentage, that would also help with decreasing margin of error. And if she asked the question the opposite way, what would you do to increase margin of error? You do the opposite. To increase margin of error, increase CI, or increase standard deviation by decreasing the sample size. So you do the opposite of what I wrote if it was increasing margin of error. But decreasing, you say these two. The other question that she asked was from a previous test 2, which is related to the concept of single ANOVA, which is usually a complete question ANOVA will be part of the final exam. But this question was a bonus question to see if you guys can do it. So the question was, as a step of establishing their rates, automobile insurance company is interested in determining whether there is difference in the mean highway speed that drivers of different group age drive. To help answer this question, they selected a sample of drivers in 3 ages. So they took drivers in 3 different groups. They divided the sample of drivers in 3 different groups. The first group under 21 years, second group 21 to 50, and the last group over 50. With 20 subjects. So in this group, they have 20 drivers. In this group, they also have 20 drivers. And in this group, they also have 20 drivers. And the engineers recorded the speed, and it was given in the ANOVA table. So they give you the information in the ANOVA table, and they just want you to fill in the blank. So, first column was called source, for source of variations. And it's between groups, also called treatment. And you have within groups, also called the error. And here you have total. You have SS, DF, MS, and F. You're given this number. You're not given this number, you're given the total. And you're also given this MS number. And the goal is to get to this number here. And there are a lot of different, here, don't worry about it, don't worry about it, don't worry about it. So we have 1, 2, 3, 4, 5, 6, or 7 numbers that we need to figure out. Okay, so going back to the questions, they're comparing 3 different groups, 20 in each, you always start here with the degree of freedom. The degree of freedom for the between or the treatment is number of groups minus 1. So there are 3 groups minus 1, so degree of freedom is 2. For the within or the error, it's the big sample minus number of groups. When we say big sample, it's the complete sample, which is 60. The 20, the 20, the 20. Minus 3 groups, 57. And for the total, you just add them. But you don't need the total anyways, but show that you add them. So, anytime if he asks this bonus question, you start with the degree of freedom, and that's how you do the degree freedom for each. Now in the first column, these 2 values must add to the total. So this plus this must add to the total. If you're given this and this, but you're missing the middle one, you minus. So it would be 4, 1, 2, 6, 3, 9, 8 minus 505, 2707. So you minus these 2 numbers, 4, 1, 2, 6, 3, 9, 8 minus 505, 2707. The number here is 3, 6, 2, 1, 1, 2, 7, 3. You need to get this number and then get this number. To get the MS number, it's usually SS divide degree of freedom. So you take whatever the SS number and divide it by the degree of freedom. So you take the 505, 2707 and you divide it by 2. 505, 2707 divide 2. That gives you 252, 6354. And this one is given, but if you have to calculate it, you would take this over 57. So 3621, 1273 over 57, and that would give you the same number. So MS is SS over degrees of freedom. And finally, to find the F, you divide these 2. This number over this number, and that would be your answer for the table. 252, 6354 over 635285. And that will give you 3, 9, 6, 7. 9767. This is how you felt. I mean, again, you will get this into more detail when you cover the ANOVA, and I think you're probably doing it now. But this is a bonus question to see if people can at least fill in the information in the ANOVA table. So yeah, please review everything we did today and assignment 2. I'm gonna send you both the midterm that we did and the bonus questions. So if you have any questions, of course, you can always let me know. Good luck.